All right. So today we got the drain motor off of a dishwasher. I did the. I don't know if you can see that. This is off like a Frigidaire or something like that. I think they're all kind of the same. All those major brands are kind of the same. Tore down the other motor, the whatever it was, the pump motor, a while back, thinking that was the issue. Turned out not to be. So replace this thing, and it looked like this O-ring was leaking on that one anyway. So, well, this O-ring is the O-ring that might have been leaking. Well, don't really see anything wrong with it, but it's going in the trash anyway, so may as well have it apart. So we've got a tiny impeller here. One thing that's interesting is this thing's cogging, which is usually a brushless motor, but only 2 inputs here, so I'd be very surprised if this were a brushless motor. Oh, so there's the whole commutator. So that's going to be a permanent DC magnet. Let me get my get a paper towel. So yeah, you can see the delineation between the poles there. So that's a yeah, it's permanent DC magnet. Got a seal here, rubber seal, and then this is kind of a bushing. It feels like nylon. Huh, that's interesting. Looks like that's completely sealed away from the rest of the motor. All right, so this is the body. So this guy sat in here, that's an interesting design. So essentially no water can get to the electronics. There's a plastic shield between the armature of the motor and the rest of the actual electronics. That's actually kind of clever. I like that. All right, these are the windings. So this would just be an AC motor then. A 2-pole AC motor. Does that make sense? Yeah, but it's got to have some sort of, there's got to be some sort of shunt winding or something like that to get it to turn. So how does that work? One other thing to note here, it appears that in the back of this is just a bushing. I don't see any way I'm going to ever get that out of there. But that appears to be, yeah, the center's not spinning. Appears to be just like a piece of rubber or something that the back of this is spinning in. Doesn't really make a whole lot of sense, but something like that. All right, so we got an electromagnet. There's the laminations. Don't see them delaminating or anything. I wouldn't think that that would be something you'd be overly concerned about with this, just because... sorry, I can't think and talk at the same time. This guy is more than likely a thermofuse. So if it gets hot, it's going to blow out. We look up the part number on that. Looks like it's a 17AM/D, 150 degrees C. Yeah, so thermal fuse. So that's going to blow out if this thing gets too hot for some reason. So if it locks up or there's a short or anything like that, it's going to blow that out and kill the motor. I suppose we could check and see if it's still intact. I'm fairly certain this thing was spinning. And it appears to be. We could snip it just to make sure that we're not seeing. seeing continuity back through the coil because I was showing 0.1 ohms. Here we go. It's like I had these all set out ready to go. All right, so, yep. Nothing wrong with that guy. So, fairly simple device. Oh, I guess this wants to get shut off. I don't really see how, because normally you need some sort of offset pole or something to get these things to start spinning. Oh, I know. I bet I know what happens. So this has no start capacitor or anything like that. What probably happens is the other motor, I'll link to the other video, the other motor starts the water rolling through because when these things start, so if you can imagine, the AC is going to come in here and it's going to flop the fields back and forth, right? Yeah, that makes sense. It has to be AC because there's no way that it would flop the fields. Otherwise, you'd just get one. You see both those coils are hooked together. So it's going to flop the field back and forth, but there's without some initial impotence, something on this spinema thing, you're not going to get any rotation. The field is just going to sit there and swap back and forth between the two poles. So what I'm guessing probably happens is the other motor starts the water flowing through. This thing's going to be spinning ever so slightly. It engages the power and allows this, and the fact that it's already spinning allows it to go. And then it kind of, its own inertia is what kind of keeps it spinning, or keeps the magnets going around from pole to pole. So I'm guessing that's probably what's going on here, because I don't see any other way for this to self-energize and spin. And you can see this with if I had an AC motor, I'd show you, but if you remove the start capacitor on a standard motor, it'll just sit there and buzz. But then if you take it and you spin it, it will spin on its own. So anyway, kind of interesting. Hopefully that is informative to somebody. Thanks for watching.